Before we begin, I would like to take a moment to acknowledge that we are located on Treaty 6 territory. And today is actually kind of a special day because Brian is also on Treaty 6 territory. Usually he is out east, but he's at our head office in Edmonton, Alberta. And today we have Brian Wiens. He is our managing director at Canada Wildfire, and he's going to be talking to us today about Modeling 100, basics to modeling. And I'm really excited to see such a diverse crowd here today. Different experiences, different places they come from, different job experiences, modeling backgrounds. And I think we're going to have some really great interactive discussion. So today's going to be a bit different than our typical webinar. It's going to be much more interactive. Brian's going to run through how we're going to handle the interaction and discussion today. So with that, I would like to hand over the reins to Brian Wiens.
Thank you very much. My sound is coming through loud and clear?
Yes, you are.
Excellent. Thank you very much. Welcome, everybody. I'm really glad you could join. As I was getting ready for this whole process, I started off thinking, I don't have enough content, but I think we may have ample to go. So we'll try to move through things fairly quickly, and just wanted to let those of you who don't know me a little bit know a little bit about myself. So I actually have been with Canada Wildfire since the summer of 2023, or summer of 2020 rather. So it's been just over 3 years that I've been with them, and I normally live in Southern Ontario, so actually in the area of the Mississauga Nation, and so it is nice to be actually here in Edmonton and be able to present to you. The weather is almost as good here as it is in Ontario, so that's pretty cool. My background, having started talking about weather, is actually as a meteorologist. So I worked for Environment Canada for a good number of years. And so I have probably my deepest roots in the meteorological field. And then when I moved, and I say back into fire, because I actually started as a weather tech in a fire center, I really relied, and actually I found very useful, having the context of meteorology. So the talk that we're going to give today, I sort of picked a title when we were trying to decide something. And the whole idea is that I want to walk through a number of different things, but also do it in a way, as Karen mentioned, that is a little bit more interactive. And here's sort of a rough roadmap for the day. And so basically the titles in green are where I'm going to be looking to get feedback from the group. And I'll remind you again in a minute here, but the idea is that I'm going to open up a whiteboard, and if that all goes according to plan, what will happen is you will have an opportunity to add and put points on the whiteboard. And one of the things that's worth thinking about is, because we're recording this, your name will also show up on the whiteboard contribution. So if you want your name to be changed or more anonymous than what's on there right now, you can go to your screen, and the 3 little dots there should allow you to change your name to something that you want shown. So you can see that I've got my sort of full name, and I'm fine with that. And if you are, that's cool. But I just want to be sure people were aware there is that option. So what I want to do is I actually will talk almost not at all about wildland fire today as such. And I want to step back a little bit and talk about a number of different things, but in such a way that we're actually talking together as much as you actually can on a virtual climate. So that's why I have 4 sort of separate blocks of time where I'm going to be looking for feedback from you. I will have some comments on those topics afterwards, but my guess is we will have covered some of what I've got, plus a whole bunch of other ideas that are in there. So when you start doing a search for model, or modeling, one of the things that almost always shows up is the whole idea of the fashion model. And so the whole idea that there's a place where somebody in unbelievably interesting or bizarre clothing, who are absolutely spectacular examples of human show-off clothing on a runway. And so that's the kind of thing that often sort of ties into modeling when a lot of people think about it. But the runway there, even though it's a place to sort of show off, I guess, if you like, exemplars of humanity and exemplars of design, is one way of looking at models. But then, just because I want to try and get us to think a little bit differently today and think about a few other things, here's another example of a different runway. This is actually a stretch of road on the Carretera Austral that serves both as a roadway and as a runway. And the only real hint that you have in this particular image is that little windsock there sits at the side of the runway, so that airplanes landing have a bit of an idea what they're dealing with. So the point in actually putting this bizarre set of pictures together is to help us sort of open our minds and it gives you a bit of a hint of maybe the bizarre way I've been thinking about this whole problem. So the first thing that I want to do is actually come up with a way to define what is a model and come up with a definition, because there's so many different ways to think about it. There's so many different perspectives, so many different understandings, but I think it's an incredibly broad word that it is really useful to think about from a number of different perspectives. So what I've done is I've created a whiteboard in Zoom, and it will have a set of tools that will show up on the left-hand side where you can sort of add a comment. And the first exercise is to come up with a definition of a model, and really want it to be as short as possible. 5 words would be ideal, but certainly try and keep it under 10 words as possible, as at all possible. And as broad a scope as you want, any kind of model, model car, model airplane, model society. I mean, those would all be candidates, I guess. But I want to do this under 5 minutes. So once I actually set this in motion, I want you to have an opportunity. And I just remind you again that your name will show up on the whiteboard and then on the screen as you contribute to it. And if you don't want, whatever you want your name to be sort of put in posterity, and hence on our Zoom, our recording of this Zoom call, please change it at this point so that you're comfortable with that. So I'm going to stop sharing my screen here. And if all goes to plan, I will now open a whiteboard. And so we should have a whiteboard. Are you seeing a whiteboard? We see names and people putting it on there, so go to it. Your options are on the left, and you can add comments and ideas. Diagrams would be perfectly acceptable. I'll give you about 5 minutes. I'm going to leave the whiteboard up for about another 15-20 seconds, so if you can finish off what you want to type, that'd be great. And I just want to comment on a couple things that I see on the whiteboard while people finish off. And one of them is that there is sort of varying levels of people that people have tackled, fairly specific, all the way to describing a system, to very, very broad, something I think was something along the lines of a visual representation, a theory, an informative representation of an object, person, system, simplification of reality. I'm just grabbing the ideas here as I sort of skim around. A numerical simplified representation allows you to recreate, attempt to simulate. Anyways, there's some very interesting pieces that have been added in there. I'm going to count down 5, 4, 3, 2, 1, and then I'm going to turn it off and go back to sharing my screen. Thank you, everybody. Okay, closing the whiteboard now. And I'm going to now share my screen again. Start screen. There we go. And so these are just some ideas that I ripped off from the web, a number of different things that reflects, I guess I aimed for very high level. I didn't try and be overly specific, but the whole idea that comes up in a lot of these little phrases is what we've got something that we're trying to represent a number in another way, a way that we're trying to actually make perhaps accessible, perhaps it's a way of trying to figure out how to understand something. Oops, sorry, that wasn't supposed to happen yet. I must have clicked in the wrong place here. Stand by. There we go. And so what ends up happening is that when we're talking about models, there's a whole bunch of different ideas, but almost all of them talk about representing something in another way, in a way that's more accessible, more easily, in a framework that we wouldn't be able to do. And then really the next exercise that I've sort of set up here, sort of stuck up a couple seconds early, is that I'd like you to actually come up now with some fairly specific examples. So describe a typical model, a very specific model, again, very short, few words if you can, or a type of a model. And I'll try and do this a little bit more quickly, so it'll be about 3 minutes is the plan. So we will exit out. I'll bring up another whiteboard. And these are the examples of models. So you should have a board and you should have access to it, which I see people going to town, so have at her. Thank you. I note that a few of you have been having some hiccups getting in and out. Thank you for your assistance in not finding your way back in. It's very helpful to see. We only tested this with a few people, so I think we have on the order of 50 folks participating today, so we're maybe straining the system a little bit. I'm going to start counting down the last minute here, please. And while everybody types in their last little bit and what have you, I want to note that feel free to use the meeting chat too to share ideas or make comments if that works better. And you'll be able to do that through the whole session, of course. And with all the information that I'm seeing showing up on this whiteboards, we will figure out a way to transcribe and summarize that and sort of make that available when we put this up as sort of an addition, when we put this up on YouTube, to have that additional sort of feedback, because I think following what actually is going on during this session is going to be a little bit tough to follow a YouTube video. But I want to note, I guess, a few things here that I see we've got a fairly broad scope of things that people, I think I saw somebody make a note about a model aircraft, or basically a scale model of something. Just trying to grab a few here that sort of caught my interest. When I scroll around, does that mess up your screen? I bet it does. Sorry about that. Anyway, about 30 seconds left. But I think there's a lot of really neat ideas here. There's some very specific ones, a forced succession model, the whole idea of using finite elements to do partial differential equations, rate of precipitation. I saw one on PM, heuristic models, fire behavior. There's a million different ways you can actually, things that actually fit under the category of models. And I think people are catching a huge range of those. And so I think that's really cool. 15 seconds. Feel like I'm announcing sort of the live and on air coming to screen near you. And as I noted, I'm actually not planning to focus primarily on fire behavior, although I think that the concepts and the things that we're going to walk through here are going to be very applicable not only to fire behavior, but an awful lot of it. Going through this, we not only gather some really interesting feedback from the participants, somebody who managed to invert their entire screen. That's pretty cool. But we'll also be able to hopefully get people to think just a little bit differently, add some new ideas, or refresh things you've thought about before. I'm going to shut down this whiteboard in 5, 4, 3. Thanks very much. Okay, I'm going to share my screen again, and I will show you some of the things that I wrote down for examples or types. And what we have showing up there is, of course, the one that I put up there was specifically sort of intended to be just a little bit different. The whole idea of a mental model. How do we actually process the world around us? How do we ingest information? I was chatting with my son this morning before we got on about the whole idea that we don't remember, or we don't store memories quite the way we think we do. We're not nearly as good at it as we fancy. Really good example is if there's a fairly traumatic, particularly a highly emotional event, different people will register different facts and will remember different things. And sometimes that can lead to some significant conflict in the reports. And that really has to do with the way our brains filter and accommodate and adapt to what we actually see around us. The other one that I sort of ran across and thinking about this is a model of history. There's a whole bunch of different ways to actually interpret our historical background. And so there's a certain thing that's very typical in academia. There's certain thing that historians do, the single significant individual kind of idea where there's key people in history that change the whole thing. But then there's also the perspective where we look at history in the context of a larger community and how the whole society relates within itself and between the people. The other one that we've had some experience with recently in Canada wildfires, the whole idea of a logic model. How do we actually identify all the individual steps that we want to take to go from inputs, resources, people, money, data, to actually get some kind of outcomes where we actually see changes, we actually see the world around us change a little. There was some ideas here, the whole idea that we have physical models where we represent something like flow over a car, which you see in fantastic advertisements, with a wind tunnel, which is a physical representation of an actual process. And you can do that on a full scale with the car, but often if you're trying to model flow over something that's much larger, you have to make some adaptations to your wind speeds, your viscosity, your turbulence levels, all those other kinds of things, that you actually get something that's representative or similar, if you like, to the actual thing. Water channels are really big for a whole bunch of different reasons, how do waves interact. I imagine many of us as kids played with water channels of some sort, whether that was damming the gutters outside of our houses or playing on sand and water tables. How does water flow? How does it erode? How does it move? What if we put a barrier in the way? What happens? That's done, I guess, for both recreational and educational kinds of purposes. Architectural models, when we're building a house or when we're renovating a house or when we're working with some kind of a physical structure, what's it actually going to look like? A physical model that we sketch up or represent that thing helps people look at how does the space interact? What are the things that we didn't think of, but did we actually really just plan to put an electrical outlet in the middle of a glass wall or something like that? And those physical representations help us see some of those relationships and some of that. And we saw this, I think, in the whiteboard, too small or larger, or something like a molecular structure. So if we had a CO2 molecule, it's going to look something like that in your classic chemistry class with sticks and balls and that kind of thing. So that's one of the ways. But one of the places I want to go, and we'll spend a little bit more time on this later on, is the whole idea is that we actually observe using some kind of a model or some kind of a sampling model, because we can't ever take completely perfect representations. There's a saying that says that nobody believes the results of a model except the modeler. And the counterpoint to that is everybody believes the results of an observation except the person who took it. And I think that's worth thinking about a little bit, that we actually do model many, many different ways in our lives. But since I had mentioned slide rule in my title, I thought I should actually show you at least a slide rule in the slide rule nomogram sort of idea. I believe the circular slide rule on the left is an aviation calculation slide rule, which is small enough that I can barely read the things on it, but it's probably still in use by an awful lot of pilots to calculate some of the key factors that they need to know in terms of elevation, altitude, and that sort of thing. And then on the right, for the meteorologist in the crowd, there's a geostrophic wind scale, which uses a physical representation of the spacing on a map of known sort of scale and projection, so that you can actually calculate a geostrophic wind, which of course is a model in itself of what the wind is actually going to be. That's a way of representing it physically and using it in a very practical way. And then for the meteorologist in the crowd, this is a tetragram, which is pretty much unreadable, I'm sure, for all of you. And maybe that's kind of the point. On this one sync diagram, there is pretty much an entire thermodynamics course sort of packed in there in the various lines and various relationships that describe many, many of the fundamental processes that go on in the atmosphere. But it's a tool that's incredibly useful in a number of different contexts. And of course, as noted, a number of you had mentioned, there's certainly mathematical representation where we take a physical process and reduce it to a set of equations. In the classic sense, we would do that in deterministic, or basically, this is the inputs, this is the outputs. We've got a way to close that set of equations, and you're going to get pretty much the same result every time. But then what has become much more common in the last 15, 20 years is using ensemble approaches. We run a series of that projection, either changing the inputs, changing the model, sometimes actually introducing different turbulent characteristics in the model to get a spectrum, and then you start to get a probability of results, which leads naturally into the idea of statistical models, where we look for relationships. And in some ways, artificial intelligence, a lot of the things that we're doing with large language or large data set processing is really like statistics on steroids, whether we're using large language models or fuzzy logic or neural nets. So the next step, the next exercise that I'd like you to participate in is an exercise in what are the goals or what are the applications of models. And at this point, we're starting to think about what are the kinds of things that we would like a model to do, or what are the kinds of things where we can identify something where a model might really help us. So it's another whiteboard exercise. So I will screen sharing from here, and I will launch a whiteboard. There we go, got the right one. From the whiteboard. And we did a test scribble on this before we started for the day, but this is break down as briefly as you're able, some goals and objectives or applications, maybe is better word, fundamentals. And again, I'll give you the 5 minutes. A lot of these will tend to be longer, but if you can make it short, way to go. Okay, 5. Very much activity, so we can actually shut this down. Again, there's some really neat ideas on here, and so thank you very much for the input. I'm sure many of you who are watching this evolve are like me and have been unable to read everything that's put in there, but I've tried to skim through a bunch of them. And it is, I would say, has captured most of what I had, and probably certainly is a superset of what I had. So there's some really good things here. And again, we commit to actually transcribing this and making it available to other people. So I'm going to close the whiteboard now. And I'm start sharing my screen. And here were some of the things that I wrote down as the kinds of things that we want to do. And I would say I did this in a bit of an order, and maybe this is a good time to repeat the caveat that I'm not a fire modeler. I have a vague or rough idea of how fire models work, but most of my experience has been with meteorological models and air quality sorts of models, with a little bit of dabbling as well in hydrological models. And so a lot of times when I think about a model, it's actually as a research tool, as something to understand a process, a relationship. And how do we actually do something? Can we actually look at a particular thing, particular interaction between a cause and an effect? And I think we saw that show up in a number of different things. But really, one of the places where I've used models most, having been a number of years in operational meteorology and also trying to support operational meteorology for a number of years, and then moving also into the fire world, the whole idea of predictive science is really, really important. And a friend of mine used to have, or a colleague of mine used to have, the tagline on their email was, "The measure of a science is its ability to predict." And I think there's some truth to that, but we also know that there are no perfect models, and so they're also used to test relationships. Do we actually understand something? And then another one of my colleagues, who we've done a number of different experimental runs with, he said, one of the things you can do in a model is you get to play God. You get to do things that are only possible in the model for either practical or ethical reasons. For example, it would be totally unethical to actually have a physical release of a toxic gas in downtown Vancouver. But in fact, it was done in a number of different ways in preparation for the Olympics. What would happen if somebody did this? How would we actually respond? Where would the impact be? And so you have an opportunity to do some experiments that are very significant in terms of possible implications. The downside is someone could actually misuse that and find the optimal place to actually create an awful lot of it. But I think a lot of things that a model really can do is it helps to understand and illustrate a relationship. So if we change the wind speed, what's going to happen to our output? Is the fire going to, I'm talking fire here. Is the fire actually going to move more quickly? Is it going to move in the direction we explain? Is it going to help us explain a particular example? But it also helps us to pass on that information to each other. And I toyed with doing this interactively, but I think I'm going to just end up yakking for a little bit now for a while. But the whole idea of how do we go about choosing or building a model? And I think you'll see this sort of a sequence of ideas repeat where we started, hopefully, but also it's really important to know what you want to get out of it. What on earth are you going to do? What is the really important output? And why are you going to be doing it? And the other part is, what do you want to have that model change in the grand scheme? Is it actually a response, an outcome, if you like, the way somebody's going to do things differently, where different decisions are going to be made, where there's going to be a different level of understanding? And then the other thing that you need to know, if you're trying to change a direction, you're trying to change a response, or you're trying to guide a response, then you really need to know a lot of factors about how fast does that have to come. Do you have 5 minutes? A lot of air quality, for example, you run incredibly long simulations because you're experimenting. You can actually wait weeks to months for the output from the model. But if you're trying to predict what's going to happen in a weather example, what's going to happen to a particular weather event, you need to have that guidance really, really quickly. And so then you also need to know how much precision, how precise an answer is actually useful. And then what's your accuracy? What can you actually do for accuracy? And that's a really important question to be discussing and thinking about. And so that comes to the whole idea, what can you do? What's possible? Obviously, and I saw this in a couple of the suggestions for models, that you'd have some kind of a representation, you'd have a reliable prediction, you'd have a reliable fire boundary, you'd have a reliable a growth model for a forest. There's a whole bunch of places where you'd really like to know that, but a lot of times you don't actually know the key inputs. And the other time is sometimes you run down a bit of a rabbit trail too. I'll give an example actually from ship icing. There was a whole bunch of work done at the University of Alberta over the years, ship and all kinds of other structure icing as well. And they spent an awful lot of effort looking at the thermodynamics of the actual water droplets. And then a colleague, a friend of mine, actually said, you know, there's a number of different factors that affect this. Is this the one that really matters? And so he did a bit of analysis, stepped back a little bit and said, okay, there's a number of different factors. It's the way the droplets are actually formed. It's a factor of how the ambient wind speed is. It's an ambient, and particularly in ships, exactly what the superstructure looks like. And they went through a whole bunch of different things. And it turns out that the thermodynamics of the water droplets was probably the least significant part. But people were tackling it because it was something they could actually make some progress on. The other ones were really, really difficult problems. Sort of help them reevaluate and say, we need to figure out how to look at droplet production. What actually causes spray that's going to start to accumulate on the superstructure of the ship, for example? What actually causes icing to occur on airplane wings? What causes icing to occur on power wires? And then the other thing, of course, is what data can be used. What do you actually have access to? Do we actually know the precursors really well? Do we know what the wind field is going to look like? Do we know what the precipitation pattern has been? And then the other question, of course, that always comes in these things is, what kind of resources do we have? Do we have just a really enthusiastic, happy team? Or do we actually have some money and some real skills to work with? And this is just my token dog picture for some reason or another. The other thing that I want to spend a little bit of time on is the whole idea of observational models. I mentioned this earlier, but I think it's really important to note that most of the time we never get we never have complete understanding of what's actually happening right now. We are always making some kind of a modeled approach to it. And a really good example, I think, is the whole idea of using hotspots to actually identify where a fire is and what's going on. And this is one from the middle of summer this past year. I just grabbed it off the Canadian Wildland Fire Information System website. But it gives you an idea of what was actually going on late in the afternoon on the 13th of June. You can see there's hotspots scattered all across Canada. And those hotspots, for those of you who are familiar, this won't be any new information, but basically you're taking a pixel and making an estimate of whether there's enough radius of energy, enough power actually coming off in the radiation to give you a convincing argument that this is in fact a fire hotspot and not just noise. And you never, or I shouldn't say never, oftentimes that pixel isn't entirely the same kind of situation. So say it's a fairly high resolution pixel, it's only a kilometer square. Well, unless your fire is actively burning over that whole area, you have totally consistent fire over that whole area. What you're actually looking at is an average value taken over a pretty big area. A whole square kilometer can vary an enormous amount. Activity was actually there for fuels and what your radiated energy is. If you make an assumption that whole pixel is the same, or a certain percentage of that pixel has to be burning in order to get the kind of power that you're getting back, but it's a pretty coarse kind of thing. And I mean, we can zoom in a little bit more closely, and here's a few examples of the kind of thing. And you can take the hotspots that have happened in the last little while, and you can make some estimates of fire parameters. What's burned where? Has there been hotspots? And you know, and so this is really the same image, same time, but then zoomed in and see how you can see the individual hotspots from a number of different satellites using a coherent or a collaborative kind of algorithm between them so that it's fairly similar. but you actually have a bunch of different data sources that you're trying to put together to come up with a bit of a picture here. The other one, just because of my meteorological background, I wanted to talk about wind a little bit. You know, there's always certain number of assumptions when we do a wind speed. We give you a wind speed and we give you a gust, and you're observing that in a particular thing. And those standards and those kinds of things were actually set up with a specific goal in mind. So the standard WMO, World Meteorological Organization, or the International Civil Organization of Aviation, they have standards that they want for a wind speed. It's on a tower that's 10 meters high. It's got very little significant interference around it. And the whole idea is that you want a wind that's intercomparable between regions so that you can actually look at things from a regional or a large scale analysis kind of approach. But it's also the whole idea of having a consistent reporting. For example, in the aviation world, pilots, if they know that this is the wind speed that's reported over the runway, they assume that where that tower, that anemometer is actually situated, the way it's actually averaged, is going to be the same at all the sites that they're flying into so that they can compare. And if it's a wind direction from 300 degrees and it is blowing at 28 knots, then they have some idea what that looks like. If it's gusting, they have some idea what the implication is for their aircraft. But sometimes that's not the information, or those are not the data that we need for a particular problem. So, this is an example where you can see that there's probably a prevailing wind because of the way the branches sort of set up on this tree. But the really important part might actually be what's going on inside that forest area, forested area, what's actually happening within the canopy. How does the wind flow through there? How does it change? Of course, there's all kinds of other meteorological parameters you could talk about, but we're actually thinking, what is the wind doing there? And that's a really important factor for drying. It's important certainly once you have fire going in terms of how it's going to behave. And then, of course, it just gets more and more complicated as you think about it. But if you collect data and you put it in there, you have to be sure that you're actually using it appropriately, because you can easily misuse the data very, very easily. And I put this, I think I was done with the wind. I put this particular phrase in. A friend of mine, again, another one of my colleagues used to have this. They were data folks, and they put this in, and they said, if you torture data enough, if you work with it and you manipulate it, you can actually get it to tell you anything you want. And I think it's exactly the same thing with a numerical model. You can do the exact same thing with a model. You can actually push it way beyond where it's appropriate, and you can get answers. And you can get maybe even answers you're looking for, but that doesn't mean that they're really good answers. And so, I was going to spend more time on sort of how we use models, but I decided that actually probably what's more important, and so what I've opted to do now is spend a little bit of time on, once you have a model, once you're actually getting some results from it, and whether it's an observational model, whether it's a conceptual model, physical model, or a numerical model, you have to think about how you're going to actually pass that on to your audience. And so I would like to spend another exercise block of time discussing communicating results. What are some of who's a probable audience? Who are you actually communicating that information to? Is it to a decision maker who's trying to decide how to respond to an event like a fire? Is it the general public? And then, so what I'd like you to do is say, here's an audience, and here's the kind of objective. This is why I would want, our organization would want to share model results with them. And then if you can fit it into fairly brief kind of phrases, how you might present the information. What's a sort of an effective way to do that? So then I will stop sharing my screen here briefly, bring up another whiteboard. And launch the communicating model results. Have at her. Again, about 5 minutes for this, please. Okay, things are slowing down a little bit in terms of input, and I did not actually prepare any examples of this for a couple of reasons. One is I wasn't quite sure what kind of feedback we'd get, and I actually can't claim to be an expert at communicating models because the bulk of the time that I've used models has been in a fairly confined information. In an operational meteorology situation, you have a fixed format that you're going to produce based on what you use as the models, and a lot of the other places I've been involved is actually more in the research world, where you have a fairly fixed trajectory, a fixed pattern for how you would use those sorts of things. There's a few points that were made here that I think are excellent, and I think are really useful. And if I don't catch yours, it's because I may have scrolled past it. But I think one of the ones that I like is the whole idea of making visuals and then you write a narrative around them. And somebody else also says, you're telling a story. You're actually creating something that people can latch onto and really grasp. And I think there's the whole idea of actually putting context, I think it shows up in a couple different places. The whole idea of defining assumptions and limitations. And then you can present an idea of the accuracy or the confidence. And that's incredibly useful, particularly when you're making decisions that could be either very expensive or very significant from safety. And I think the comment that a picture is worth 1,000 words is incredibly correct. You have very complicated situations that come out of a model, and so you can distill it down into a really accessible kind of a picture or some kind of an image on a map. I see the idea of a time series graph or a chart. And I think there's a whole ton of different things that actually go into it, and it depends on who you're talking to. Comment about the idea of the appropriate level of language and the appropriate level of tools. To a media kind of outlet, it's going to be different than if you're talking to incident command or something like that, I guess. Highlighting key findings, dashboards. That is an interesting one. Dashboards can be tricky because people can sort of do a little bit of their own slicing and dicing and misinterpret the data. And so I think that makes a compelling argument that there's a lot of cases where having just raw results can be a little bit dangerous. It opens the door to having some difficulty. We got a couple of ones that I ran across that I wanted to. And I think I like this one in the public, in particularly the idea that when we release model results or something informed by models, we're trying to motivate behavior change or protective kind of an action. So simple terms, variety of people can relate to, and here's somewhere else, but the whole idea of very specific options. This is what you can do in response. Enough to provide context, but short enough to make sure it gets read. A very good point. For elected officials or leadership is to recommend action or explain decisions. I think both of them are incredibly important tools. The whole idea of transparency of inputs. I think you run and I'm going to paraphrase what's written down here in a couple different boxes, but the whole idea that you're balancing off a realistic expectation of what you can do, but also with enough confidence and enough context so that people can actually say, is this something I need to respond to and how can I respond to it? Because I think that's really important. So, okay. With that, I'm going to stop sharing the whiteboard. And again, thank you very much. That's very useful information that you have put in there. And I hope we can find a way to make that really useful for others. And I think this is one of the things, and just a little bit of a rabbit trail here, but I was at a meeting in Whitehorse the last couple of days where there was really good representation from the agencies in particular. And that was the story that I heard a number of different times. It's really tricky to know how to feed the information, and a lot of times it has to be very customized depending on who your recipient is. And if you have an angry or a very scared recipient, they're going to hear things very differently from someone who is calm and not overly panicked yet, for example. And those are really important things. Go back to the whole idea, why are you actually sharing results or really sharing any information with them? So that's really sort of what I had set in terms of sort of the formal part. We still have a few minutes, and I wanted to throw the floor open for questions, but I do that by wanting to note that we have a number of partners who are noted on this particular screen as being key players in terms of what we do, and they're actually the members who help fund what we do. We also have a number of other partners that we work with, and we are always open to having more partners join us, ideally in sort of full-blown membership, but certainly in any other way that you want to collaborate with us We are aware that although we have some fantastic participants, there's opportunities that we're missing because we're not aware of some of the things that are going in some of the agencies that we don't work with regularly. And we do have some informal relationships with a couple of organizations just to make sure we have more channels. So there's a number of different ways that you can interact with us and sort of join in some of the things that we do. Then we'll listen to something that's a little bit digestible because I think there's an incredibly high volume of information that's been collected in there. So at this point, I will throw it open for questions. If we don't have any, I have a couple more slides that we might get to if we don't, if our conversation starts to lag a little bit. So I will close my screen and go back to the other screen, and I'll turn it over to Karen to sort of run her on some of the questions that might come up. And you can either put your hand up or you can enter them in the chat for sure. So.
Thanks, Brian. Yeah, I was just going to say, feel free to participate however you're comfortable. So if you would prefer to post your question in the chat, I am more than happy to read it for you. If you're comfortable putting up your hand and unmuting, feel free to do that as well. So while we're waiting to see if anyone has questions, Brian, thank you. That was a really good presentation. I'm really curious about different ways of communicating and communicating to different audiences. And if you know of any resources perhaps that might be out there for helping people for learning how to communicate outputs from models to, for example, like an operational audience versus a general public audience or a specialized audience, or if you had any kind of rules of thumb or rules of hand kind of for the elevator versus staircase versus lecture approach type of communication. Brian, did you hear my question?
I did. Sorry, I was
Okay.
hoping someone else would jump in with a response rather than me. Actually, could you repeat it again, just to make sure that I catch all the points?
Sure. I was rambling a little, so I'll try to make it more succinct. I was just curious if you had any thoughts on general resources or rules of thumb for people to think about when communicating models or model outputs to different audiences at different, I guess, time limits. So I know we are quite often taught to think about kind of an elevator approach. So 30 seconds or less, climbing a staircase, you got 2 minutes, or, you know, a full-on lecture when you have all the time in the world to communicate. And I know some different people who have a lot of experience in communicating have different rules of thumb. And I was curious if you'd be willing to share any of those from your experience with us.
Certainly, and at risk of repeating myself, I think two pieces are really, really important in that. One is to have a vision in your mind of what you want the results to be of having that communication. What do you actually want to see? Do you actually want them to take some action? Do you want them to send you money? Do you want them to have a better idea? And I think the other thing is you have to know who your audience is as much as you can. So who's receiving it? I mean, you would explain something very differently to an 8-year-old than you would to someone who had just finished a whole bunch of research in using a complex mathematically analytical kind of approach. But I think a number of the things that are showing up in the comments are certainly where I would be. If you can show things on a picture, I mean, I love maps. And so, I mean, I love the fact that Karen's got a map in her background. I think that is a way of describing things in a way that most people understand. They have some idea where things fit in. And so you can describe it in that kind of context. That's really helpful. But sometimes we have situations where it is a 3-dimensional kind of thing. And again, if you can use an image to actually help display that, I think those are two really important things. The 15-second elevator, you have to really be careful of what you're going to say and how you're going to go about it. The staircase is a little bit more. And of course, in a lecture, you have a lot of time both to prepare as well as to really craft what you're going to, pick out the responses to who you're talking to and what you want them to do from the whole thing. So you have a lot more time to actually craft what you're going to deliver. The other one is, and I'm terrible at this, is try and not talk for the whole 15 seconds. Say enough to actually throw out a question so that you actually get a little bit of feedback. And sometimes you have great, deep, incredibly cool thoughts, but they're not quite ready to hear them. And so that's where it's really important to actually ask that question back. And in some ways, and I mean, some ways, that's what I was trying to do here is I wanted you to talk about what things that struck you, and then I would try and fill in some things that struck me. And then hopefully between us, we actually improve and mutually improve the understanding. And I mean, and the fourth thing, of course, this is feasible in a lecture, but you're not going to be able to do in an elevator. I love three-dimensional visualizations where you can actually take the domain and flip it around. And particularly when you're looking at, for example, smoke dispersion or any kind of meteorological process, that's a really important kind of thing.
Thank you. Some great resources are being shared in the chat as well. And I see that Neil specifically has posted about visualization. And I will note that I'm very thankful to Neil personally for teaching me early on in my career the importance of putting important information on visualization. So if you're producing a map, making sure you have those key things, legends, scales, things like that, and also perhaps even a caveat or limitation bar. Limitations and caveats are very important in my mind when communicating models. So thank you, Neil, for teaching me that. We have a really good question in the chat, which is how do we tell when a model is good enough and when do we know to stop improving? And I think this is $1 million question.
Yeah, I love that question. And I'll actually don't know if any of my former meteorological colleagues are on the call. I didn't notice any, but one of the things that and I'll take a circuitous response in terms of the way I tackle this. One of the things that I noticed there is that a lot of the decisions about what needed improving and how that was going to be improved came from the modeling team. They would have an S1 score. They would have some kind of an analytical gradient analysis that said, this is what we're not doing very good at. We can make it better. In the 30 years I was with Environment Canada, I never recall once where the modelers came and said, what do you need? What would really be helpful to you? Now, I'm sure they did because they worked more closely with some districts than where I was working. But a lot of times that decision sits with the wrong people. And so I think the first step in answering that question is talk to your users. Is this actually doing what you want it to do? And if we could improve it, what would be better? And that's where the modeler also has to take a pretty candid response and say, yep, actually, no, this is the best we can do on that. Or these are the options. And I think it's a superb question. When have we gone as far as we can go with a model? And it also then hails back to looking at that model and say, why did we actually build this? What was it supposed to do? Is it doing that? And then some of those other questions fall into place, but absolutely fantastic. So.
And I think that segues really well into a little bit of self-promotion as well on this end. Our December webinar is going to be Christoph Dale talking about Burn P3 Plus and some of the changes that have been made to that. So that's a great example. You can tune in on, I believe it's December 8th, the first Friday in February. I should check, or in December. It's going to be December 8th. Yeah. So second Friday, sorry. And we have a lot of really great comments again in the chat. I see some links to papers to look at, for example, coloring and things like that for communicating. Modelers should also thoroughly document key decisions and describe model strengths and weaknesses in order to share this documentation with others if required. I think that's really important to note as well. Oh, I see a hand up.
Yeah. Yeah.
Okay, I'm Neil. Are you able to unmute or do you need me to sit? Perfect.
Let's see if that works. Thanks for the webinar, Brian. Enjoyed the session this morning. Just a thought, like this is I think a really good kind of foundational starting point for students and researchers that are kind of getting into modeling, but also a good review for folks like myself that have been doing it. But what kind of came to mind as you finished is the real need for a communications course around modeling. And just looking at this past fire season, I've heard a lot of researchers being asked to speak on radio interviews and to the media. I've had to do it more than I've ever done in my career. I know our weather forecasters go through some training that helps them kind of provide operational briefings, and they kind of hone that skill. But for others, you might be thrust into communicating your expertise and your model of results to a number of different audiences. And if you haven't done it before, it can rattle you. It can challenge you. And so I would love to see a course developed around that. I think it would be a really nice complemental skill to kind of give to folks to kind of going off into disciplines that will require them to communicate their model outputs. And I don't know that maybe there's one. I don't know, but I never really saw a course like that when I went through school. So I'll leave it there, just kind of a comment and just saying thanks, Brian.
Excellent observation there, Neil. And I'm not aware of one. We'll maybe should cast around a little bit, because certainly some people are better at communicating complex information than others. And just as a counterpoint, I'll give you an example of a former colleague of mine, long retired, so he'll remain anonymous, but was asked by the media about a particular development, and he was unable to put it in accessible terms. And his response, that of course made the headline, is, "You'll have to trust me. I went to university." That doesn't work very well. I can give you that as the negative space. So.
Richard, I see you have your hand raised.
I do. Yeah. Thanks for the presentation, Brian, and some additional comments, Karen, as well. I just have comments as well, not really questions, but I think the last points that Brian made and the last slide that showed, partners, just kind of clued into me that, a model can also be the way that collaborative projects work between organizations. And then, the fact that you mentioned that researchers may not have gone to their users to get feedback. And, I think that's part of a model too, how things like a project development lifecycle or software lifecycle might work. We've got a model as to how this project should proceed. And, part of that is getting feedback from people and trying to improve it. So I think we've kind of got models built on top of models to allow for some of these things to happen. Thanks. That's about it for now.
Thanks very much, Richard. Jonathan actually asks a question here, lessons we can take from the meteorological field. And what's interesting is that back in the old days, and less so now, but they actually did have formal briefing courses where meteorologists were taught how to deliver information to users. And so there was a media one. I spent a fair amount of time doing aviation, spent a whole year supporting military operations on a base where you're briefing pilots and navigators one-on-one. And in that particular situation, they had an opportunity to send feedback. If they thought your presentation sucked, they were not shy about letting you know. And so those kinds of training and learning experiences, I think, are transferable to a large degree. We can actually sort of see examples of best practice, and then we can also try and teach some of those things. And we should see if something exists. I'm not aware of something specifically, but one of the things that came up this last week that I heard from a number of different people, both Canadian and we actually had a number of American representatives at the meeting, is that fire behavior analysts, for example, are called to present information all over the place sometimes. And so they have to really be able to dance. And so some of them sort of learn it on the fly. Some of them find it a lot harder. So.
Those are all great comments. I'm just looking in the chat here, trying to scroll through. Sorry, I went dead there for a little bit. I had to replug in my laptop. I did not realize it was not charging.
So while we wait for more comments to come in, oh, we got Matt McDonald. There's an expert on communication. So
Matt, I don't know if you want to unmute or not, or I can read your comment from the chat, but Matt is a weather person with BCWS, and he has spent the last 15 years. I see he's on now, so I'm going to let him talk.
Yeah, thanks, Brian. Great talk. this morning. I really liked it. I liked how you kind of skirted around, models get really complicated, but when we take a step back and remember what we're actually looking at and all the, caveats and different models, it was an interesting exercise. I like that. I really think, there's the science of modeling and the super techie, geeky modeling world, but then there's the interpreter of models. And as meteorologists, I feel like we're essentially storytellers. We look at tremendous amounts of different model outputs. We've never had access to so many models. And ultimately, you have to come to the table with a relatively concise story. And oftentimes that's done under tight timelines and stressful conditions, particularly in the world of wildfire. And so I think, yeah, it's kind of turning away from science and trending more towards the art of communication, of communicating clearly, succinctly, not dumbing down the story too much, and that you're still communicating the complexity of a story, but at the same time leaving the client, the user, the audience with something that they can then go and make a decision about in an educated way. And knowing your audience often comes to mind, adjusting your message to that type of audience. So if I'm being interviewed by the media, then you're telling it in a somewhat simpler fashion. In the wildfire realm, our audience is huge, right? We have people with PhDs who are super sophisticated and can appreciate the complexities, and others that are kind of first year recruits that are just like, yeah, tell me which way the wind's going to blow. So yeah, it's I think it comes with time, and it's a craft that you continue to develop, and finding mentors, who are great communicators. I've had access to quite a few, one of which is online today. And yeah, it's practice, and being humble, learning from your mistakes, because inevitably, particularly with the media, Brian, you gave a good example there. They're going to grab that soundbite, and often it's not the one that you wanted. It's something that maybe you got a little loose, a little comfortable, and they're like, oh, there it is. But yeah, I'll leave it there. Communication is a whole field of itself.
And maybe I'll tell a little story on myself, which maybe illustrates some of what Matt is saying. When I was doing the military briefing, I grabbed the wrong briefing package for one of the flight crews, and we used to actually change buildings to do because I delivered in person. And so I delivered, about 15 minutes of death and destruction, basically warning seasoned flight crews to bring air sickness bags. And someone sticks up their hand and says, "Where exactly did they tell you we were going?" And I looked at the notes that I had, and I said, "You got the wrong package. It's going to be great for you. That's the briefing," and walked out. And they said it was the best briefing they ever got. Anyways, so this is where you have to be able to admit you were wrong, as well as being able to have a bit of, we had a rapport with them because they knew we worked really hard to try and give them good information. I did want to address a little bit one question that was asked about the context of risk modeling, and I won't try and answer that, but I will say that the presentation by Chris next month should address some of that. And it won't be the main focus of his, but he's probably a better position to answer that certainly than I am, about whether the concrete, really analytical kinds of approaches versus anecdotal insights are, how do you reconcile those? Because they both have value if you use them appropriately, for sure.
I'll add to that as well and say there are a lot of people on this call who could probably answer this. I don't know if this is a form in which they'd like to do it, but if you do know individuals that work at fire management agencies that are participating in fire behavior analysis, my suggestion would be to reach out to them. There's one person on this call, they've told me that it is a mix of art and science doing fire prediction modeling, fire behavior forecasting. So they're definitely taking that stuff into account in some way, but you might be best served to contact them in person individually.
Yeah, and thumbs up on a lot of those comments. Science communication courses would be fantastic. Not all universities have them, but they're fantastic. And certainly, having done a fair amount of media courses, I guess they kept sending me back. Anyways, is incredibly valuable. The media is If they're your friends, they are really good supporters. If they're enemies, they're really good teachers about what you shouldn't do. And so the opportunity to have that formal training on how to deal with it, yeah, totally. 2 thumbs up for that one. Karen, maybe I will, just because we still have a few minutes and this won't bring the conversation to a close, but maybe I'll show a few more images that sort of I thought might be just interesting, particularly in the whole idea of communication. And so I put together grabbed a couple pictures that I thought might be interesting. And you may find them useful, you may find them ridiculous, but I thought, well, here's a way of looking at things a little bit that we can actually apply to models. And first one is a picture I found some time ago. But I think you can apply it to a model in a number of different ways. Last week, someone made the comment that when you only have a hammer, then everything starts to look like a nail. But the other thing is sometimes we want a way more complicated solution than we really need. So if all you're doing is driving nails, you don't need anything too terribly fancy. And it goes back to the whole idea that this is a way of thinking about what you really need, what's actually useful. The second one is sometimes the model doesn't really do what you thought it was going to. I think this is a beautiful example of something that was supposedly intended to do one thing and it doesn't work at all. At that point, you just don't buy it again. You're done. And then this is maybe where I will sort of, I think this is a really neat picture for a number of reasons. One, I have grandkids, so I get to play with Lego from time to time, but this is a really interesting one that I think is illustrative of a number of different points in modeling. One is, wherever possible, use what's out there already. Use the blocks, use the pieces of information, use the tools that exist, and apply them as well as you can. The second one here is we actually have, and this is not intended as an advertisement, but MegaBlox, Duplo, and Lego actually are compatible, which is something I learned while trying to find pictures for this. And a lot of times you can build what you need using MegaBlox. That's all you need. Sometimes you need Duplo and sometimes you need Lego. So the resolution is really important. But a lot of times too, the big blocks support what's going on in the medium-sized blocks, which supports what goes on in the smaller blocks. The whole idea that you're actually getting finer and finer resolution by relying on coarser or broader kinds of pictures, kinds of things. And a lot of modeling is done that way, where we actually we don't have the computational power to run at the resolution that we'd like, and so we actually have to zero in fairly selective and fairly narrow kinds of things. And this is what we see on a lot of nested modeling. And I do have another picture. The whole idea is also in modeling that a lot of times, and this is starting to get into the nuts and bolts of modeling, but a lot of times the large scale feeds the medium scale feeds the small scale. But where it's really nice is we can actually get feedback going in both directions, where the smaller scale is actually informing. And a fairly good example is Environment Canada has been running firework for a number of years now. And it has been a one-way model. Basically, it takes the emissions from the satellite detected hotspots. It creates an emissions field, generates it, disperses it, actually does some chemistry on the whole thing, moves it around. It's an incredibly sophisticated and pretty reliable way of actually predicting what's going to go on. But the actual smoke fields or the pollution fields were not actually feeding back into the meteorology, where they've done some experiments where that actually goes in, and it represents fairly well a situation where there was enough smoke that the daily temperatures didn't get nearly as high as what had been predicted. And so there was the ability to actually show the shading, show the mid-atmospheric reflection. And so being able to move both directions is actually very important. It's a nice goal for modeling. That's just a couple of pictures that hopefully people will find either interesting or amusing. And I think I'll turn it back over to Karen in case there's more questions and more comments that people want to make.
So there was one more question just posted in the chat asking if you could share your views, Brian, on model sensitivity, that is trying different inputs to see scenarios.
Yeah, sure. I think it's a grand idea. And I think that's one of the things that a number of us have been talking about, including Chris, who's going to be presenting in a month, is certainly an expert on this, and a number of his colleagues, because I'll lean into the fire model area here, because a lot of times we run a predictive model of fire growth. And a lot of people who are running it, and a lot of the analysts will take a look at it and say, you know what, I don't think that fuel is exactly right. And so they'll change it to what they think is more representative. And so we have an awful lot of experiential knowledge that has existed where people have done those sorts of experiments. And that's good, but it's hard to really share that in a consistent way, or to even use it in a really consistent way without a very systematic approach to that. And this is where you would run the same model over and over again with different model inputs. And I think that's the point that that Joel was actually making there, is that model sensitivity to certain responses. Does the model actually respond to, well, let's say terrain slope? I mean, if it doesn't, probably the model's wrong. But I mean, if it does, or if it responds too quickly, well, then again, maybe the model needs tweaking, or we just really need to understand how important it is to get that particular input, that particular parameter, input parameter correct. I very intentionally did not go here with this talk because I wanted to think in the bigger picture, but those are incredibly important discussions that we need to have. And I think it's very high priority research in Canada and beyond. Take a look at those models and say, well, what happens? What happens if we've got the fuel law? What happens if we've got the meteorology law? What parts of this really make a difference? And we have enough case studies of actual events where we know, or we can make a pretty good estimation of what were the drivers of that particular model behavior, what made it do, or sorry, that fire behavior rather, what made it behave in the way that it did, what were the factors that went into it, and then we have to look at, can we actually do that in a model? And then it helps us improve the model, but it also helps us use the model wisely. If someone is spending hours switching between fuel types, or huge amounts of time before they run the model, and it actually doesn't make any difference on the output, well, then maybe they can put their effort into some place that's either at the output end or something like that. So there's a whole bunch of different ways to look at it, but I think it's incredibly important. Yeah, it's a really good point, Dan. I mean, and this is the thing I'll speak from my operational meteorology standpoint, and you're welcome to jump in and add more, but we would have access to somewhere around 5 to 12 models, some of them which were quite similar and some of them which were quite different. And part of our job as operational meteorologists was trying to distill which one was actually the one that we should be leaning towards, or how could we get a bit of information from that particular model, information from that model. And so it's really hard for a model user to try to determine the best model. The tendency is that and I'll speak for myself, I used to develop preferences. Oh, I like this model better in this particular situation. It was quasi-scientific, but it wasn't really systematic. It was a lot of gut, and sometimes I was right, sometimes I was not. So for the model developers to fight it out, I think there is really an arena to actually solve this, where we should get the modelers together and have the shootout. And so you've got this particular fire growth model. Let's try it in different situations, see which one performs better. And then hopefully the people who are running the model and are using it to give advice are in a better position to actually quantify how good that advice is. The other side of that, of course, is this is one of the approaches to ensemble forecasting, which I think is, in my opinion, is one of the ways to get an awful lot of information about probability. You run a bunch of different models on a situation, and then you get a spectrum or a range of outputs. And hopefully, when all the models agree, then you can have some confidence that this is a likely output. But it gives you a measure of uncertainty, as well as ability to give some probabilities, and basically some risk assessments to people who are making decisions on how to respond. Yeah, good points, like that. And yeah, totally agree, Joel. I did a lot of intuiting, I guess, as an operational forecaster.
I think thinking about sensitivity in models is really important, and things like sensitivity analyses can help understand, keeping in mind things like confounding factors, or inputs that might be double, triple, quadruple represented, especially when you're looking at system inputs instead of individual inputs is important. And I like Joel's saying that sometimes the best model is chosen by your intuition. And I firmly believe that our intuition is just our own sensitivity analysis. So sometimes you hear about people just, especially people with local knowledge, they just know what's going to happen. And they've already done all that processing in their head, right? But all really great points. So we got about 8 minutes left. I'll leave it open for a bit here and we'll see if anything else comes in through the chat. If anyone wants to raise their hand on mute, please feel free to.
In a comment by Jen sort of scrolled off my screen, which I didn't comment, but I think you actually make an extremely good point there that it is pretty seldom that one model is always better than others. And so really understanding where they work and having some idea of that uncertainty is going to make for a much wiser application, a much more appropriate use of the models.
I guess another point is that depending on urgency, time sensitivity, and cost, there can potentially also be opportunities to run models in tandem, whether it's after an event or during, if you have something running that you can actually use to make decisions. You can run things in tandem and compare results after the fact to get a bit of a read on where certain models performed better than others. So Brian, I'm not seeing any new posts other than thank yous. You're welcome. Oh, we got one. Brian, what are your feelings about rules of thumb?
That's a good question, because I think there's a lot of rules of thumb that reflect what you would call implicit knowledge. They basically develop usually because they worked or because somebody thought they worked. It's really hard to I was going to say to quantify how well they work and that kind of thing, because a lot of times rule of thumb relies on interpretation of the operator. But maybe not a bad example is the old rule of thumb: read in the morning, sailors take, or meteorologists or firecasters take warning. Fire people are thrilled if it's read in the morning. Read at night, sailors delight. The whole idea that actually is based in physical principles is one where you can say, okay, typically in the Northern Hemisphere, if it's read in the morning or read at night, rather, you basically have the clear sort of sun path that tends to indicate that the next number of hours anyways, you're not going to be getting an awful lot of moisture. Whereas if it's the other way around, just because of the way the clouds tend to be, you likely have clouds on the west. So so sometimes those things actually do have really solid physical things. Sometimes the rule of thumb is right for the wrong reasons too. And so they're valuable, I think, in asking the question, why does this work? Why do people use this particular model? And sometimes they're valuable just because they do work. And so it's certainly been I wouldn't want to throw out the baby with the bathwater.
So I see one more question here. Deterministic models usually flatten probability curves and lead inevitably to over and under predictions. Do you have any general wisdom on applying and communicating deterministic results in a probabilistic world?
That's a hard question. Probably the correct answer is no, I don't. But I think it's a really important question. I don't know if there is general wisdom on doing that. I think the key to using a deterministic model is understanding how it works, which to some degree actually starts to move you very quickly into a probabilistic world. And so I think wherever you can, I am becoming more and more convinced that probabilistic approaches are probably the most scientifically rational and the most useful for users. sometimes computer restraints require a deterministic or very narrow probabilistic approach. And then if you understand what you're doing, you're in a better position to make some kind of a logical interpretation. But that would be the closest I'd come to having advice on that, because you're absolutely right. A deterministic model picks a solution and will do the same solution from the same inputs every time. And we do know, I was actually having a conversation with someone a couple of days ago where they said, could you actually introduce some variability, some statistical noise, if you like, into the way your model runs? It seems pretty empirical to do that, but it's a great question. And I think it sort of speaks to some of what you're talking about. It's important to recognize that we are in a probabilistic world. So yeah, kind of a lousy response, sorry. Yeah. Yeah, good points. Both Valentin and Neil, I think those are very good points. You can do it. Sometimes it requires a bit of computer resources, which if you need something really fast, you might not be able to do. But if you possibly can, there are ways to get probabilistic models by a number of different methods that, yeah, add to your information, add to your scope of understanding. That's going to make hopefully make your advice and your recommendations more useful and more sophisticated.
There's some great comments in the chat. Would anyone that's still on here just pop a yes or no in the chat if you think it'd be valuable for us to share the chat log, or at least siphon out some of the questions, comments, and resources and email them out to you? Let me know when that's something that we can do. We'll also try to find a way to include some of the key resources and comments into our YouTube video when we post this sometime next week on YouTube. So we have about 2 minutes left. If there's any last burning questions, please feel free. We have 1 minute now. Please feel free to get them in the chat. If not, I'll keep chatting while we're burning down the clock. But just a reminder again, December 8th, we will have Chris Stockdale talking to us about Burn P3 Plus and a bunch of the new and exciting stuff that's being done with that. So Brian, I'm going to let you have the last couple minutes here and close out the meeting.
Probably it would be better if I were to unmute. Thank you very much, everyone, for participating. The value, hopefully this created an opportunity for some of you to think about things a little bit differently, but a lot of the value I see is the input that you put into those screens that we've collected, and this conversation at the end has been very useful. I'm quite passionate about tackling some of these things, and so any ways we can make models more useful and more appropriately used, I think, is a step in the right direction. And I think you've provided us with some really good suggestions and paths that we might be able to go forward with to make it that way. So thank you, and I hope you enjoy this. And anybody who ever wants to give a seminar, I'll just speak out on behalf of Karen. We're always looking for people to present, and I see there's lots of people here with thoughts, and we might have opportunities for you. So let us know. Thanks again. Have a really great day and a good weekend, and we will see hopefully all of you next month.
Bye everyone. Thank you so much for joining us. Have a great weekend.